This video is going to cover a principle that is very helpful in figuring out the total number of outcomes that can occur in a given situation. So the basic premise here is that if you're looking at a bunch of different categories of things, so maybe my categories are going to be if I'm having like breakfast, lunch, and dinner, and there would be some choices for each one or something like that. All you're going to do is take how many options there are in each category and multiply them all together. That's what the blue part is basically telling you here. And I'm going to show you how that plays out through a few examples. So, on that first example there, we have a restaurant that offers 3 appetizers and 2 entrees. So for right now, what I'm going to do is show you a way that you can do this, like if you had to get this before, what you probably would have done. Let's call our appetizers A, B, and C, and my entrees can be 1 and 2. So what I'm going to do is pick one from this list and one of them from this list right here. So I could have, for example, A1, A2, or A3. Wait, sorry, there's no A3. You could have A1 or A2. You could have B1 or B and 2, or you could have C and 1 followed by C and 2. So altogether, we're looking at 6 different possibilities right here. Now, instead of making that list right there, it wasn't so bad with just these choices, but say we had much larger lists, it would have been really kind of a pain to do it that way. Much easier option. There were 3 choices for this. There were 2 choices for this. So altogether, we have 3 times 2, which is 6 possibilities. You can see all 6 of them listed right there. Let's look at 2 more examples of this. These next 2 are ones that definitely wouldn't work out very well if you're just listing out your choices because the problem is just too big. We're going to look at a computer password for this one, consisting of 3 lowercase letters followed by 2 single-digit numbers. So altogether, there are 5 kind of categories in this one. If you picture, like you're going to type in your password right there, each letter of the password is like a different category. I have so many choices for this one, so many for this one, etc. So when you see problems like this, I really do like making blanks to kind of picture what's going on here. For each of these letters here, I have 26 choices, 26 letters in the alphabet, and I am allowed to reuse letters, so it stays 26 for all 3 of them. Then I want to go and pick 2 single-digit numbers. Well, for this number right here, I can pick anywhere from 0 to 9, which gets me 10 choices altogether. Same thing right here, I have 10 choices for that blank as well. So I broke it up into 5 categories. Instead of like appetizer, entree, it's number 1, or spot 1, spot 2, spot 3 through 5. So according to the basic principle of counting, I just multiply these numbers together, and that will tell me how many outcomes I will have altogether. And if I do multiply that out, it appears that I get a rather large number, which is not surprising. But it's going to be 1,757,600 total possibilities with this many characters under those specifications. And our last problem right here, we're looking at a probability experiment where you're going to flip a coin, then roll a dice, then draw a card out of a deck. So you can think about this right here. There are 3 kind of categories that we're choosing from. Like I did on my computer problem where I had my 5 blanks, 1 for each spot. I have my coin, I have my dice, I have my card. So for a coin, I'm looking at 2 possibilities here, either heads or tails. Those are the only outcomes that we're going to consider here. We're not going to say it lands on its side or anything weird like that. A 6-sided die, there are going to be 6 different options there. And for my cards, there are going to be 52 different choices. And according to the basic principle of counting, I just multiply those numbers together. 2 times 6 times 52 is going to get me 624 different outcomes.